Bubbles. They're all around us in our daily lives. From bubble wrap, to bubble gum, to bubble tea, to water bubbles, and even to living in the bubble of this pandemic, bubbles have given our everyday experiences a unique pop. But there is something so magnificent about bubbles and their bubbly features, such as the same way some seem to defy gravity and glisten, but also the way others belligerently collapse. These are known as cavitation bubbles, and just the same way soap bubbles tend to fascinate toddlers, cavitation bubbles have managed to entrance scientists. Before cavitation was first observed, Leonard Euler had come up with the idea that a slipstream, or an area of low pressure, would trace behind an object moving incredibly fast enough through water. In other words, an object creating an area of high pressure would leave behind a void of low pressure. In fluids, this void of low pressure can cause them to vaporize and create steam bubbles that implode within less than 5 milliseconds, and do so violently that they can reach temperatures hotter than the sun's surface and cause some serious damage. This damage is especially seen in boat propellers and submarines. In fact, the mantis shrimp and pistol shrimp use inertial cavitation to create shock waves that break the shells of their prey and stun them. Sometimes, the implosions of cavitation bubbles can emit light as well, a process called sonoluminescence, and scientists don't exactly know why this happens. Some studies theorize that it could have something to do with fusion, sound waves, or even be a process similar to Hawking radiation. The truth is, no one really knows. What's most important though are the possible implications for cavitation, because it doesn't just occur under simple surfaces of water. It has been proven that cavitation can take place inside the human body and also in space. In a study supported by the NSF, it was found that whenever one's head was exposed to sudden translational impact, cavitation bubbles formed and collapsed, producing a shockwave through the brain and damaging the brain's surface, which suggests that the severity of head collisions may be dangerously underestimated. Even more out of this world though, a 2019 ECEA research paper suggested that just the same way cavitation bubbles can be created in ship propellers, they could also be naturally created through the vorticity phenomena of a black hole. In other words, the variety of low pressures created by the event horizon of a black hole due to cavitation could be a possible reason for dark matter. Today, we learned that some bubbles aren't very pop-friendly. With violent implosions, cavitation is capable of doing some serious damage, but with sufficient research, it's just as capable of partaking in significant progress and endless advancements in both the science and medical fields. So, I think it's safe to say that our future looks pretty bubbly.